So in example 1, we want to find limits analytically. That means to find them algebraically without using a graphing calculator or sketching the graph to look at the limit like we did in our last examples in the notes. We're going to start by recalling that a limit is the y value the function approaches as x approaches a given value. And to evaluate a limit using direct substitution means everywhere we see an x in the expression, we're going to substitute the value the limit is approaching. So the limit as x approaches 1 of the quantity x squared minus 2x plus 1 all divided by x can be evaluated by substituting 1 for x. So instead of x squared, we'll have 1 squared. Then minus 2x is 2 times 1 plus 1, that's in the numerator. And then in the denominator, instead of x, we put a 1. Then 1 squared plus 1 is 2, minus 2 times 1 is 0, and 0 divided by 1 is 0. So the limit for example A is equal to 0. Okay, in problem B, we're going to substitute 1/6 in for x to find the limit as x approaches 1/6 of the function 2 cosine of pi times x. So we'll have 2 times the cosine, and then the argument of that function will be pi times 1/6, which is pi over 6. And if you recall from what we learned about the unit circle, the cosine of pi over 6 is the x coordinate of the angle in the unit circle that measures pi over 6 radians, and that would be equal to square root of 3 over 2. So we have 2 times the square root of 3 over 2, and the 2's cancel, making the limit the square root of 3. Okay, then in example C, we want to find the limit as x approaches 5 of the log base 25 of x. So we're going to substitute in 5 for the x. So we'll have the log base 25 of 5. And recall from our unit on logarithms that that's asking the question 25 to what power equals 5, and that would be the 1/2 power. 25 to the 1/2 power is 5. So go ahead and pause the video, and you're going to try problems D, E, and F on your own, and then when you've got an answer for each, you can resume and we'll go over those together.